Hello students, let's see this question of Irodov, question number 1.64. The question states there is an inclined plane in figure 1.11 having angle alpha 30 degree. With the horizontal, there are two masses m1 and m2 and the ratio m2 by m1 is eta 2 by 3. The coefficient of friction between m1 and the inclined plane is k equal to 0.10. The masses of the string and the pulley are negligible. So we have to find the magnitude and direction of acceleration of m2 when the formerly stationary system of masses start moving. So let me draw the FBD of the system of m1 plus m2 as a whole, but without friction first. So obviously there will be weight of m2, m2g acting downward direction, and the component of the weight of m1 along the length would be m1g sine alpha, and component of weight normal to the inclined plane would be m1g cos alpha, and there will be a normal reaction. And because m1 cannot leave the inclined plane, so normal reaction will balance to m1g cos alpha. So normal reaction is m1g cos alpha. And there is a friction between m1 and inclined plane. So it is written that after releasing, the system start moving. So obviously the friction is kinetic friction, and the magnitude of the kinetic friction between m1 and the inclined plane is the k times of n. That will be k into m1g cos alpha. And now I want to see m1 and m2 as a whole, and I want to straighten the system just to decide which way m2 will move. So this is m1 and I'm straightening the string, and this is m2. Along the length forces I'll show. So here the force will be m2g, and in this direction the force will be m1g cos alpha. And just want to decide whether on this straightened system m2 goes right or towards left. And to do that, obviously the whole system will move towards the net force. So let me calculate m2g divided by m1g sine alpha, and gg gets cancelled. m2 by m1 is given in the question eta, that is 2 by 3, and sine alpha is sine 30, that is 1 by 2. So this is 4 by 3, which is greater than 1. So it means that m2g is greater than m1g sine alpha. So it means that m2 will go towards right in the straightened system, and they will have a common acceleration magnitude a like this. And in the inclined plane system, obviously then m2 will go downward with acceleration a, and m1 will go up the incline with the same magnitude of acceleration. And once that is decided that m1 is going up the incline, so direction of kinetic friction on m1 will be on the downward direction like this. So kinetic friction between m1 and inclined plane is fk, and that is a k m1g cos alpha. On the straightened system, that kinetic friction will act like this, k m1g cos alpha. Calculation of the magnitude of common acceleration is straightforward. So I'll again take the combined system of m1 m2 on the straightened system, and that common acceleration is the f net along length divided by total mass. And the benefit of taking the combined system is that we don't have to write two equation. Tension will not be needed, otherwise there will be tension, and then we have to eliminate tension, so we can do directly. And now that f net along length, always take the direction of acceleration positive. So that is a m2g minus m1 one net, that is one mistake I've done. This is not cos alpha, this is m1g sine alpha. This is m1g sine alpha. So m1g sine alpha and minus k m1g cos alpha and divide this by total mass of the system, which is m1 plus m2. And now let me divide this everything by m1. So if I divide this by m1, and before dividing, I'll take a g common. So m2 by m1 is first eta, and here m1 dividing, so I'll remain with sine alpha, and here I'll remain with k cos alpha minus k cos alpha, and in the denominator we will have dividing by m1 also here, so eta plus 1, and that is the final answer. And the direction of acceleration of m2 is the downward direction. Thank you.